So that's all I'm going to say, other than to welcome Nick and just remind people that he's a graduate of the ABI, a very distinguished graduate of ABI. He's held professorships at Oxford and King's College London. He's come back here as the Dean of Engineering, and I can say, being a member of the senior management team in the university, how highly regarded he is by all his peers and among the deans and directors in the university. So welcome, Nick.
Thank you, Peter. I have to say, what a great honour it is to come and talk to the ABI. I mean, I really do feel like my sort of research and academic career started in the early days of the ABI, and it's a great honour to come back and be invited to talk to you. I have to also say that honour was quickly changed my perspective when I was told I was asked to talk about collaboration. And the reason for that is really this image here, which is a reminder to tell you all of the parable of John Smith, who is no relation to me. And John Smith, after living a fairly unremarkable life, headed up to the pearly gates and was met at the pearly gates by St. Peter. And St. Peter said, "John, we really can't tell what to do with you. You know, the committee is hung. We can't, you haven't done anything really terrible to send you away, but, there's nothing really exceptional to welcome you in. So we've asked them to stay and listen to you. And if you could think about perhaps something which would sway them, something you've done which is a remarkable achievement, which they can listen to and think about, and that might really help you sort of come through and be welcomed into heaven." And so John thought fairly hard, and he was welcomed into the building, and he said, "Right, well, I'd like to tell you about the day when the kitchen sink overflowed, and I managed to rescue the cat from the flood and put it on the table." And St. Peter looked at him and said, "Yeah, I wouldn't go with that one." He said, no, really, it was a major flood, and the cat hated water, and I was really quick, and it was, a great thing of trust." He said, "No." He said, "Look, Noah's in the audience." And that's a sense of how I suppose I feel coming here, because I don't want to patronise people about talking about collaboration, because I think the ABI is really one of the great models of collaboration across the university. It is a place where, for many years, well beyond the time I was involved, has welcomed a whole diversity of skills. And it's created an environment where those skills can kind of work together, an environment of trust where people can actually share, knowing that they'll all benefit cumulatively. And also a place where they can do things which perhaps arguably a bit risky and have high return. And that's, I think, something which in the university context is critical to our raison d'etre. So I'm going to talk a little bit about those themes. Again, these are largely personal insights from my experience. I'm going to talk a little bit about some of the projects that I've been involved with, both in Europe and back here, and where the collaboration was, I think, a key feature. And I'm going to talk a little bit about the engineering faculty at the end and what I think we can offer. And hopefully I'll get through quick enough so that we can have some discussion, which is really what I'm interested in and what I'm here for. So I'm going to start with Adam Smith, again no relation, one of the great iconic economists from the 18th century. And his iconic book is The Wealth of Nations, and he talks in that book about the Law of Comparative Advantage. And the particular example which I want to highlight is the Law of Comparative Advantage, and the illustration he uses is of two silversmiths in the village who make knives and forks. Silversmith 1 in any hour of work can make 10 forks and 8 knives. Silversmith number 2 in any hour of work is much less efficient, can only make 2 knives and 1 fork. And the question is, should they collaborate together? And from the immediate perspective, well, let's have a show of hands. Is this a collaborative arrangement or not? Silversmith 1 is demonstrably better in every quantitative sense, and it could just get on with things. Anyone want to make a case that there is no value in collaboration here? I'm happy to have a show of hands. Anyone want to make the case that there is a good case for collaboration? There's a whole lot of people who haven't voted. So the argument here, and the argument that Adam Smith makes, is that actually it's not about the relative skills of the two silversmiths. What it's about is the relative skills that they have in the two functions that they're working on. So for silversmith 2, who's making 2 knives for every fork, a fork is worth 2 knives. Whereas for silversmith 1, who's making 10 forks for every 8 knives, there's only 80% value of a knife relative to a fork. So they can trade and both be more efficient in terms of their time. And that is the fundamental basis of collaboration, which really extends beyond science, beyond individuals, within groups, and free trade internationally. And it's something I'd like you to think about, because in terms of how we work as scientists, we all deal with limited resource. And the most basic limited resource we have is our time. And the question of collaboration is sometimes, how can I get something that I could never get? What's that unique skill that I don't have? And I'll show some examples of that. But it's also, how can I contribute to the greatest impact? And that's the question of, how do I deploy my time most effectively, and where can I work with other people who can deploy their time effectively to do something that otherwise we wouldn't be able to do together, or we wouldn't be able to do within the resources that we have. And it's an ongoing issue in science, and I used to think about this probably a little simplistically, and we think about this as 2 people or 2 groups, and they both have expertise, and those expertise overlap somewhere, and in that overlap they have a common interest. I used to think about the ideal collaboration was where that overlap was just enough so that they could work together, but not completely overlapping as to why would you work with someone who did exactly the same thing as you. And I think to some extent that still holds true. But I suppose as my career's progressed, I've developed a slightly wider view of what those expertise can actually mean. We think of expertise often in terms of technical terms, a modeler with a physiologist, someone who's an experimentalist with someone who does the analysis. But certainly in my career, I've seen a wide range of things. This is what I would think of as a sports analogy, 2 people who are both trying to play basketball well. I hope the small guy is quick, because his talents are going to be needed in that particular environment. But in my own childhood, I used to watch these 2 characters. Ernie, on your left, was the guy who came up with all the crazy ideas. And I suppose Bert was the internal critic who decided which of those ideas were worthwhile and which of them weren't. And this was relevant for me. I have one of my very close collaborators who was actually a graduate student of mine. And I can tell you now, to this day, our projects, I'm Ernie and he's Bert. My role, and we've done this for many years, but it's only in the last couple of years that we've actually realised and been able to talk about it. I come up with a whole series of ideas. Some of them are good, lots of them are not, and he's very adept at picking out the ones which are going to be relevant, going to be interesting, and perhaps going to have legs. And it's a really fun process in terms of that exercise. So I think about it not just in expertise, because our expertise actually overlaps in lots of ways. Sometimes it's about personality. And I'd extend that further into expertise in writing. Some people are very good at raising money, but often require people to work with in terms of defining what those projects are and how they make sense. I talked about proposing questions and hypotheses, critiquing ideas, which is what my image is showing here. This is sort of what it looks like once I've suggested something particularly stupid. Attracting graduate students, which is often the engine of any research environment, and postdocs. Reputation, time, and connections. And I can tell you now that certainly when I was growing up in the ABI, the senior staff provided all of those kind of things for me, and I was very lucky to be connected. I was very lucky to be able to be known by the collective reputation of the ABI, which was strong then and has only become stronger now. And I was very lucky to be able to be supported by people on a variety of income. And all of that is a collaboration which you can then move through stages as you move through your career. So what's important in that process? I'm going to say first and foremost it's about trust. And I like this image because it shows a degree of trust that I've never been brave enough to have. And from that, or underpinned by that, are a whole bunch of other things. We are in a relatively unique environment in an academic setting where we more or less get to choose who we work with. So you can get to work with people who you actually like. And that you only realize how important that is at the point that you actually don't have it anymore. So I would encourage everyone to collaborate with people that they like, that they get on with, and that they have a good time. I think there's a requirement to recognize the complementary skills, and I don't place any great precedence over the skills of being able to write well or communicate well versus being able to do technically something extraordinary. All of those are necessary, and I think if we can, the collaborations which work well is that they are valued equally, and there is no kind of fundamental hierarchy in that status. Able to communicate well, but also be able to understand people's issues. There's a kind of ongoing thing sometimes you see in teams where everybody thinks that they're solving the hard part of the problem, and they should just do what the other people are doing is routine and easy, and if only they understood that we were doing the hard part and they're doing the easy part, it would be so much easier. It doesn't really work like that. Able to share control of projects, and able to realize that people at different points in time will be responsible for different things, and that's a good thing. It's a really good thing if you can let people's ideas and be empowered to go and do things that they otherwise might not do. And then I'd also say that trust is a long-term view, and the really great collaborations I've had, and I've seen other people in the ABI as well develop, go on for many, many years. And the reason that's important is that sometimes somebody will get more of the kudos or the reputation from a piece of work. Sometimes somebody else will get more, but ultimately, A, it all tends to work out on the end, and B, and this is my next slide, this is a quote from Truman. Harry Truman, who was one of the former presidents of the US. I'm sure he was more talented than the current one. But the other point around this is that it's not a zero-sum game. It's not as if you produce a project and then you decide at the end of it who is going to get credit for that project. I'm going to get 50%, my other collaborator's going to get the other 50%, and that's what it is. Actually, what you're doing is producing something which can have enormous impact across a wide variety of audiences. And you can both receive and celebrate the successes of that process far in excess of a strict allocation of proportions. And I have seen not a lot, I have seen some relationships fall apart because people are worried about what their share of that pie is and not aware that actually overall it's the size of the pie that's important. One of the most famous examples of that is these two characters. The one on your right is Isaac Newton, who was the Lucius Professor of Mathematics at Trinity College in Cambridge. And the other is Robert Hooke, who was a professor at University College in Oxford. And they hated each other. And history doesn't portray either of them terribly favourably. Newton was accused by Hooke of being arrogant and dismissive, which I'm sure he was. Newton accused Hooke of being immoral and impecunious, which I have no idea, but the photo doesn't really do him justice. And I bring this up because they had major arguments around gravitation as to who got what credit for what ideas. There's some evidence that Hooke suggested some of the early thinking, but it was really Newton's mathematical skills that brought that into a coherent framework. But ultimately, history hasn't given Hooke, I would argue, the credit he deserves for the contributions he's made. And that is A, because of the relationship between the two, and B, because Newton lived longer and was able to rewrite some of that legacy as President of the Royal Society. It's something which doesn't reflect well on either of them, and ultimately is a kind of microcosm, a pretty famous microcosm of how you've seen collaborations break down. The interesting part about that anecdote is that this is the British pound coin. If everyone's seen British pound coins, and round the side of the coin, you can just see it there. Some of the words is standing on the shoulders of giants. And for those who know it, it's the famous Isaac Newton quote, which says, if I have seen further, it is because I have been standing on the shoulders of giants. And some historians now review this as perhaps the most famous scientific piece of passive-aggressive behaviour ever, because Hooke was incredibly short. And this was a sense that Newton was perhaps trying to point out that he had nothing to do with Hooke in terms of any of his discoveries. I still like to look at that, not quite with that sort of jaded, jaundiced historical lens, but with a sense of what that statement does represent in terms of the positive view. And in any scientific endeavour, we are inheriting a huge body of knowledge. And I think one of the really exciting places where that body of knowledge is developing quickest is often at the boundaries. And this institute has a very, very long history in terms of working at those boundaries, bringing different types of knowledge together, and you're seeing that today in the various people you have come to talk to you. And some people might recognise this guy at the back. This is Peter, who I think was doing his DPhil at Oxford in these days, in a temporary lab on the top of the physiology department. About 25 years later, I got to go and do my postdoc in exactly the same room, and it was still temporary, and the wind still howled through that process. But what Peter established at that point was a culture of collaboration at that point between largely mathematics and engineering and physiology. And all of the kinds of principles that I've talked about, I think, have applied and underpinned the success of the research and the Institute as a whole. And that's certainly something that I was very lucky to be embedded in that culture when I did my PhD, and was then subsequently went back to Oxford in Auckland, and then in the UK, and now back here. When I was a PhD, there was a sort of further element to this. I look at this, I was very pleased to see health and safety was briefed at the beginning. I looked at this photo now, and I look at the health and safety catastrophe this could be. This is me here. I had more hair in those days. And we're having the first Auckland University supercomputer being dropped in through the 6th floor of the engineering faculty. It couldn't be tipped on its side. We couldn't carry it up the stairs, so we had to carry a crane from the bottom of the car park and then lower it in through a hole that was cut in the roof. I don't know if Greg and Chris are here, but you can see them there as well. And this is the only academic who was up on the roof, Matthias Ergot, and he just looks incredibly worried about the whole thing. But what that did was added not just physiology and maths and engineering, but also, serious high-performance computing and computation. And that, I think, has been something which, in terms of the modelling work, has powered and accelerated so much of the physiome-type vision for many years now. And so that really brings in yet another element in another field. I was lucky enough when I went to the UK to get involved in another element, which brought a fourth discipline, if you like, into that collaborative mix, and that was clinical medicine. And the vision there was, as part of a series of fairly large European projects, how could we collaborate together between clinicians, engineers, image processing people, device people, because there was lots of devices being embedded, to move clinical medicine. Do we have any clinicians in the room? Am I going to... Apologies if I'm insulting the clinical community. Move clinicians, which I would argue a lot of clinical science, and particularly cardiology. My favourite joke about cardiologists, are you a cardiologist? Oh, I'm safe in that way. My favourite joke about cardiologists is, what's the difference between God and a cardiologist? The answer is that God knows he's not a cardiologist. But clinical medicine at that point took very sophisticated data sets. This is a standard MR, so fairly routine in this context. But all kinds of information, and then they compared it with really rudimentary metrics. So this is the New York Heart Association class for cardiac synchronization therapy, and basically, if your QRS is over about 150 milliseconds, and you can't walk 400 metres in 6 minutes, you get to qualify for a 30,000-pound operation, which is invasive and takes quite some time to recover from. And it seemed an enormous waste, I think, to the whole community, that we were getting all this information and then we were comparing it against largely historical metrics. And that this arrow here, I would argue, wasn't really a science, it was very much a practice. Now, I get why it's a practice. It's an evidence-based process for doing things, but there was a whole opportunity lost. So the vision, and it really was a collaborative vision for this project, was one of how do we take this data, build personalised models, and then use those models to derive a more nuanced and a more exact version of therapy. And then how can that therapy come back in terms of the treatment we would produce for the patient? And by inference, going round this loop, how could we also improve the models that informed that process? Now, that was a grand vision, and I think it really is still a vision which underpins these projects, and I think is still one of the things which is embedded in this institute. The interesting part for me in terms of the collaboration, and we did a lot of work producing a lot of very complicated models, and we were quite proud of some of the work we did in that, but it was, again, that sort of effort to investment was pretty significant. The interesting part for me was that we had all this collateral benefit which came from these projects, which was really about the collaborative environment that project created. And I've got 3 examples of this. This is, again, a standard MR, 1.5 Tesla MR of a heart. You can see the segmentation, automatic segmentation of that heart, which we did with a piece of software that Philips gave us. And we then were able to build a very Auckland mesh by fitting that mesh automatically to that segmentation. So this was really, all this really did was automate things which had been done in the ABI for many years from clinical data. There was the relative giant that we're standing on was quite large, and I think our contribution here was quite small. And to be honest, we weren't really about producing models of the heart. We didn't see that as the end goal. We were doing this because we wanted to create meshes to do large electromechanics simulations for CRT, which we did. So this was really just a step in the road, and it was a necessary step and not a goal in itself. The interesting part, and this is where the collaboration came, is after having done this, we realised we could do it for a whole bunch of other hearts. This is a hypertrophied heart. This is a heart failure heart. These are animal hearts. It's a single ventricle mouse heart. That's a LVAD heart. So we realised we could do it for other hearts, and the postdoc, who was Pablo Namata, was pretty enthusiastic, and so he started applying it in terms of other things. And then one day, Paul Gleason from Oxford, I was in London by this point, rang me up and said, "We have 2,000 hearts, and we think they're kind of different, but we don't know. Can you help me?" And it was literally about a 10-minute conversation on the phone. I said, "Well, we can produce models of the hearts, and then I suppose we can look at the geometries." And he said, "Great." So Pablo went down the day after that with a hard drive, and he came back with 2,000 hearts. And in about a week, he produced models of them all, and we did a fairly simple principal component analysis on them. And we started to segment out the cohorts, and it turned out that, yes, they were different. This is half these hearts were people who had been born premature, more than 4 weeks premature. They were being scanned at age 30 to 35, so they were full adults at this point. The other half were age-matched normals. And the question is had that loading of the heart in their early years fundamentally changed the shape? And the principal component analysis revealed that it did. Now, I illustrate this because that was a serendipitous collaboration where they had all the data, they had the need, they had the hypothesis, and we had the tool that could kind of collect into that. But in actual fact, the amount of effort for us was very little. And the magic about that particular interaction was actually the collaboration, the complementarity, and the common interest. And the fact that after that, they were so pleased, and I suppose the trust levels were relatively high, and we went and had fun when we went down there. We did a whole lot of other different studies with them, and it was fun to kind of tune out in that space. Out of that came other data sets, and there were other clinicians in that unit who said, "Well, we have comprehensive MR data. Can you do something with this?" And this required a little bit more work, but again, with relatively simple, it was really an abstraction of Navier-Stokes equations. We could then tie this down to a pressure-Poisson equation and look at relative pressures that were being generated in the heart non-invasively from the comprehensive data. And again, that has spurned a whole line of research which the postdocs and now faculty members in London are taking on and able to look at different patients and different diseases. Again, we built it for one thing. There was an interesting fit, and then we were able to take it forward with collaboration. And then the final example, and this is again our CRT example, is one of parameter extraction, which I know people do here, and a lot of people are doing in different contexts. This was a series of clinical data sets of heart failure patients, and I had this PhD student who literally worked 120 hours a week every week, and finished his PhD in about 2 years. And he went through all of these data sets and ran a series of Kalman filtering approaches to pull out what the stiffnesses of those tissues were that were consistent with the pressures that we'd got from the non-invasive comprehensive data from the previous slide. And what we showed out of that study was that actually you could start to separate out the normals in blue from the heart failure cases in red just by looking at the contraction mechanics per se. Now, in each of those cases, what my group offered was some modelling expertise, but all of the data, and to be honest, a lot of the questions came from our clinical collaborators, and a lot of the computer science and the numerics actually came from collaborators back in Oxford. And so it really was a bringing together. None of those things actually were major contributions for the group because they'd already done a lot of the work as part of their routine practice. And the opportunity was about how you bring those elements together to actually do something useful. Now, I've showed you 3 things which worked well. I'm not going to pretend that every time to talk about a project and every time you go and discuss something with someone that you immediately end up with a high impact paper. What I would encourage everybody to do is to look and explore those opportunities. And it's something I've seen almost every successful scientist that I've ever admired do in an ongoing way. Going out and talking to people, going out and being interested in what that person is working on, whether you can see direct relevance or not, and having as open a view of what that opportunity is. And if you do that, it is remarkable what will fall out. Not everything falls out, but with an open mind, it's remarkable what does. So I'm going to finish with a few comments about engineering, and I haven't inflicted upon you the strategic vision of the engineering faculty. If you would like it, I can certainly send copies. But what I would want to say is that it's been an interesting experience for me as the last 3 years as a dean, because I have had the opportunity, and it is again a privilege, to go and look at the whole spectrum of technologies and expertise in the engineering faculty, many of which are quite some distance away from my background as a biomedical engineer and as a modelling biomedical engineer. And there is significant depth and interest and diversity in a whole range of things which I really think are relevant and potentially exciting for the ABI. And I know that there are many things in the ABI which are relevant and exciting for the engineering staff. And one of my roles is to create an environment which facilitates high impact science and high quality science. And I think that's an opportunity which perhaps hasn't been fully exploited by either side in the past. And I'm certainly keen to look to explore that and to encourage people to do that. Specifically, there is strong expertise in the engineering faculty in robotics, and that's robotics which really spans life sciences through to automation and manufacture. There is a long-standing and deep expertise in materials, which starts off with composites, but is now also being augmented with plastics. And structural material. Food science is an emerging area led by Brent Young in chemomaterials. Sensors and electrical engineering, software, which is a slightly different type of software from the ABI software. Expertise, power electronics, are all areas where I think there is real opportunities to talk, and I would love to be able to facilitate those discussions. Whether things come out of them or not, I think is something that is part of that collaborative exploration. Without those discussions, you never get any chance to see that opportunity. Obviously, there's a long-standing, deep and world-leading expertise here and in this room in modelling, physiology, devices, measurement, clinical medicine, physiology and software. And if you start off with my 2 spheres, I think there is this region of common interest which is probably just about the right size in terms of what things are being brought and what things are not. The way that works is going to be through strong personal connections and people who are willing to come and listen and have those discussions. and sharing and partnerships across the facilities. So I'll finish with an anecdote. This is an editorial from the New York Times a couple of years from Tom Frieden. And he's talking about the wider engineering factory of tomorrow. And he says the factory of tomorrow is only going to contain 2 employees, a person and a dog. The person's job is to feed the dog, and the dog's job is to bite the person if it touches any of the machinery. And his basic premise of this is that as things become more automated, as information becomes more global, as expertise is able to be translated from local environments to global environments, then the need for people doing things in a specific place is going to be much less. And in fact, the opportunity to be average in a global sense is much reduced. And he finishes it with this comment that average is over. And his point is that unless you are going to be working with some of the best people, unless you are going to be really at that cutting edge of expertise, it's going to be very hard to continue to lead that forefront of research. Now, my argument, and I would submit to you today, that opportunity in an environment which collaborates within the institution and across institutions and across countries and in every other unit you can do will be much stronger than if people look to do it alone. So I'll finish there. If I have any time, I'm very happy to take comments or questions. Thank you.
So we have about 5 or 10 minutes for questions and answers. For Nick, so does anyone have any thoughts, comments? So I for one appreciated many of the photos of different scientists throughout the ages, including young Peter Hunter. It's a lot of fun.
I have others if you'd like to see those.
Yeah, so I was curious, from your perspective, during your postdoc, obviously the early days of bioengineering were sort of engineering approaches into physiology and biology, but bioengineering, there's many different avenues to talk about food science and these other areas. So what are the comparative advantages in New Zealand, in Auckland, in the Pacific, and kind of special areas where being in Auckland we might have a foothold into branching bioengineering into kind of new and untouched areas?
Yeah, it's a good question. I mean, bioengineering is interesting. I've just been in the US for the last week, and you look at biomedical engineering in the Northern Hemisphere, and it has a whole ton of different flavors. You have bioengineering departments which look like chemical departments, chemical engineering departments. You have bioengineering departments which look like mechanical departments, and they just kind of added that application. And then you have, bioengineering departments which look like kind of modelling, and there is this process of determining what those flavours are. I think what has been done in a New Zealand context incredibly well is looking at those niche opportunities at the interfaces between things. And I really do think that is the opportunity that New Zealand has, not just in terms of bioengineering, but opportunity across our whole academic sphere. Is we're very good, and this is, I think, a cultural value as much as anything else, at pulling together 2 different fields, able to be open-minded enough to get a grip on them, and then look at what that creates as you bring those 2 things together. What is it? It's the kind of cliche of number 8 fencing wire. What do I need to do? What do I need to build to plug this gap and actually be able to extract value from both sides? And the history of the ABI is starting off with modelling and physiology. And you've now very strongly through the MedTech core and very successfully built a real capability in devices, which now allows you to both interact with systems, measure systems. There is expertise in imaging. Now, all of those fields are very strong fields globally, and all of those fields have strong communities with them, and often very well-funded communities. But the really exciting part for me is still, and the really exciting opportunity I think is still, sits at that interface. What is it that you can do between imaging and devices? What is it that models can tell you about your experiment that you didn't know, which says go and do this experiment rather than that experiment, or go and rule this out, or determine more optimally the set of steps you're going to take in your research. And that's what this institute is known for, and that's what I still see as the opportunity. I would ask Peter the same question if you hadn't asked it to me first. So,
Nick, great, really like the presentation and the analogies you talked about. And I think you focused on a lot of the collaborative aspects for academics, and that's absolutely, I wholeheartedly and enthusiastically endorse that. There is another part of collaboration, and I want to sort of draw you out a little bit, and that's between the academic research, bioengineering, and the more commercial outcomes, in other words, business. And one of the things that I think in the university we're trying to get is more interaction between businesses, either large scale or indeed startups. The Institute has a long and well-recognised history of startups, but I think there's also an opportunity for interactions with larger scale companies. And just really want to push you a little bit and what your, any thoughts on what the vision is for the faculty, the engineering faculty, in terms of that collaboration in that direction?
thank you, sorry, that's great. I would send you a copy of our strategic plan.
Excellent.
Yeah, it's really interesting for me because I look at across the faculty and I have kind of was able to see all the different types of research contributions and all of the kinds of things that they're making. And the thing that kind of keeps me awake at night sometimes is this concern that we are going to continue to produce stuff and we're going to be shouting into rooms and no one's going to hear. And if you look at the enormous proliferation of papers and the relative drop in the difference in care and time, the difficulties in actual reviews, if you will. And I think academia as a whole, particularly engineering, and I would argue perhaps parts of bioengineering, and I think the ABI is probably leading the way in this sense, need to say, it's not about how many papers I write. It's not about even attention to reads them. It's about what's the impact that I make. And that impact can be made in the academic sphere, or it can be made in the commercial sphere, or it can be made in both. And it's usually a question of what the time scales are. And I think our challenge in the university, what behoves us to do, is to really invest and support the highest impact and the highest quality work on the thing. So my agenda in the faculty is to try and change the discussion a little bit away from I need X number of papers or X number of citations to say what is the change you're going to make, what is the impact that you're going to make. And a key part of that is industry and commercial. Because that provides a unique vehicle for taking research and producing that. So what we're doing in the faculty in that space, we are very close to launching what we call a NIP, which is the New Market Innovation Precinct, where we're bringing in a number of external startups to kind of work with us and collaborate with our academics. I am very strongly encouraging a number of our academics to follow the footsteps of the ABI and start to develop their own stand-ups and host that process. And to try and transform the conversation I had with some of our big stakeholders, we've got lots of those. But that conversation when I arrived was, we want your students. How can we get your students? We actually, how can we have a student relationship where you have expertise in the university you might want to call on? You have people who can provide some thought leadership. You have people who might even be able to provide some partial comment around making some of the important decisions that we have. And so that is a relationship around impact, which is really the thrust of the faculty. So it's a really good point.
Question from Ian?
Yeah, it's good. This whole area of collaboration is really quite complicated. It seems to me that very often you've got a problem and you go to seek, you've got a pain, you've got to find someone else to help you to alleviate that, and you go and find this other group. And typically, I think there's some nice balance between what you don't have and what they have. But there's a great tendency, or rather in some of us, to go after someone who's slightly better than we are. I don't think these collaborations last very long. Sooner or later you catch up to them and you become suspicious of each other, perhaps. But anyway, that's one aspect of it. I think it's a rather an area for a PhD. The other thing is, I feel that collaboration is extremely difficult to do outside of the lab when you're working on something that's really hot. And I think collaboration tends to really come into it when you've actually got something there that you can now market to someone else that's got something that you need. So I think, we can't decide the fact that it's hard to manage something when it's really hot and revolutionary outside of your own lab.
Yeah, no, without doubt. I think obviously everybody does it in ways that they're comfortable with, and some people want to have something which is finished, or close to finished, before they go and seek that. Other people are more comfortable with a much more serendipitous, open-minded discussion. If you did this and I did that, then could we do something together? In terms of, I certainly personally have never worried about going after something better than myself. I think of that in terms of what can they offer and what can I offer, and can we do something which is something we can't do otherwise together. And you do that until either you get to a point where you're no longer offering something unique, in which case you do something else.
Marriage is over.
Yeah.
So, in the interest of time, I think we should move any further discussion to the morning tea. But let's thank Nick one more time for that nice talk.